It's been over 50 years since we last left footprints on the moon with Apollo 17, and now America is trying to go back. But something strange is happening. This year, the first two US landing attempts since 1972 both ran into some major trouble. It feels like a huge paradox, right? With all our modern tech, why is landing on the moon so incredibly hard all over again? To figure that out, we've got to start with a pretty shocking number.
Yeah, this is the big question, isn't it? I mean, we have computers in our pockets that are millions of times more powerful than anything on the Apollo missions. So what's the hang-up? To really get why this is such a challenge today, you have to look at the raw numbers, and honestly, they're kind of startling.
That's it, 50%. Landing on the moon is literally a coin toss. And this isn't just one country having a bad run. Across every single nation that's ever tried it, about half of all attempts have failed. This is a universal engineering nightmare, and we've just seen it play out in real time.
So, just this year, you had Astrobotic's Peregrine lander. It didn't even make it to the moon because of a propellant leak. Then a month later, Intuitive Machines lander, Odysseus, actually touched down. Huge success, but it tripped on a rock, broke a leg, and tipped over. Now, it did send back some great data, but still, what a heartbreaking end for a $120 million spacecraft.
So what's going on here? Well, the key thing to understand is that these are not your granddaddy's Apollo missions. They're part of a NASA program called CLPS, which stands for Commercial Lunar Payload Services. These are uncrewed robotic landers built by private companies. And that one little detail, it changes the entire game plan.
I mean, the difference is just night and day. Back in the Apollo days, you had Neil Armstrong, a world-class pilot, right there in the cockpit, making split-second calls. If the radio got fuzzy, they had Michael Collins orbiting above to relay messages. Today's missions, totally autonomous. They rely on direct-to-Earth communication and engineers troubleshooting from millions of miles away. But the biggest, #1 difference, it all comes down to cost.
Okay, get this. This really puts it all into perspective. It costs roughly $1 million to send 1 single kilogram to the moon. The 2 spacesuits from the Apollo 11 mission, just the suits would cost about $160 million to launch today. That's more than an entire robotic mission. And that's exactly why these new attempts are all uncrewed.
So you might be thinking, okay, if these missions are so risky and there are no people on board, what's the point? Well, the whole goal is to build up the expertise again. It's about testing all the new autonomous technologies that are going to make the next generation of crewed missions, that's the Artemis program, way safer and more reliable. We're basically relearning how to do this so that one day it becomes routine.
So how do we actually crack this problem? Well, let's look at the next company up to bat, Firefly Aerospace. Their lander, called Blue Ghost, is absolutely packed with tech that's designed to overcome the very problems we've just been talking about.
The landing sequence is basically a masterclass in flying by yourself. Blue Ghost has to switch between different cameras, use these preloaded 3D maps, and then, when it gets close, use a special algorithm to navigate terrain it's never seen before. And get this, for the final 10 meters, when all the dust kicks up, it's flying completely blind. It's just using its internal sensors to absolutely nail the landing.
So that special algorithm, it's called SLAM. It stands for Simultaneous Localization and Mapping. This is the same kind of tech that lets self-driving cars navigate a busy street. But here, it's letting a spacecraft map a piece of the moon in real time. You know, the name is a little unfortunate for a mission trying not to slam into anything, but hey, it's an incredible piece of tech.
But just navigating isn't enough. You've got to be stable. Think about it like a car. Intuitive Machines stacked its fuel tanks vertically, which made their lander kind of tall, like an SUV, easier to tip over. Firefly took a totally different approach. They put 4 tanks on a single level, giving Blue Ghost a super low center of gravity. It's built more like a race car, making it way more resistant to tipping.
And to really stick that landing, you need the right legs. Firefly's chief engineer Will Coogan explains they're using some really advanced manufacturing. By 3D printing the titanium legs, they can control the inside of the structure, making them both incredibly strong and super lightweight. It's a perfect example of modern tech solving a classic space problem.
The design of this landing gear is just brilliant. You've got those 3D printed legs. Inside, there are these shocks made of a crushable aluminum honeycomb that just soaks up the impact. The feet have these ankles shaped like bowls so they can't get snagged on a rock. And the sensor that tells the engine to shut off? It's so simple. When a foot touches down, a plug gets pulled. Only one of the 4 has to trigger. That's it. But here's the thing. Even a perfectly designed lander can't succeed all by itself. There's a much bigger, more systemic problem we're facing, which is the total lack of infrastructure on and around the moon. The real bottleneck right now isn't just the hardware,
It's the basics, like communication and navigation.
And right now, let's be blunt, China has a huge leg up. They have dedicated relay satellites parked in a stable orbit that give them constant communication, even with the far side of the moon. Meanwhile, the US and Europe are still relying on giant antennas back on Earth, which means you have communication blackouts and total blind spots.
So what's the big grand solution? Well, it's pretty ambitious. We need to build a dedicated GPS and communication system just for the moon. NASA's plan is called LunaNet, and the idea is to create a whole network of satellites that will give future missions constant, reliable data on exactly where they are and where they're going.
And you know what? This is already starting to happen, piece by piece. Remember that Intuitive Machines lander that tipped over? It was actually carrying the very first test node for LunaNet. It only worked for about 30 minutes, but it worked. And Firefly's next mission in 2026 will test GPS signals and deploy another satellite. Every single one of these missions is laying another brick in this new lunar highway.
And that, right there, brings us to the most important point of this whole thing. Understanding this bigger picture, it completely reframes how we should be looking at those so-called failures.
Because even a mission that ends with a lander on its side is, in so many other ways, a massive win. You get priceless data from the flight. You get to test brand new hardware in the actual environment of space. Your engineers get crucial hands-on experience, and you start deploying the very infrastructure that everyone else is going to need for the future.
So no, these are not catastrophic failures. Not at all. They are the necessary, kind of messy, but ultimately cost-effective first steps of a brand new era. Think of them as the test flights for our modern-day Apollo program, building towards a future where landing on the moon is no longer a coin toss. So that leaves us with one final thought. Right now, we are solving the problems of landing and navigation. We're building that foundation for a permanent presence on the moon. The real question is, once that highway's built, what new, unforeseen challenges will it reveal for the next generation of explorers to tackle?